Now participants will get to know how to use the Venturial or the OpenFOAM GUI that FOSSEE has developed. So this endeavor is actually led by Professor Prabhu Ramachandran of the Aerospace Department of IIT Bombay. And it was initiated by Rajdeep Adak, who was our former staff, and Rajdeep is also, he is still associated with the team. And along with Rajdeep, Deeptanshu has taken it forward. Now Deeptanshu is actually leading the team of OpenFOAM GUI. He's working with his fellows and interns, and he's taking feedbacks. Actually, our initial version was released in GitHub last year, and we are actually doing many pilot on that. So today he will show you how to use the GUI for OpenFOAM. So over to you, Deeptanshu. You can start the session.
Thank you, ma'am. So, hello everyone. I'm Diptangshu, and I have been working on the OpenFOAM GUI team at FOSSEE. So, Blender is a open source software that is mainly used for 3D modeling and mainly 3D artistic stuff. But it also has a very good Python API that is exposed, and people can use that Python API to make some add-ons on top of Blender that can serve some specialized purpose for them. So in our case, we are using Blender's interface, and we have developed an add-on to generate OpenFOAM case files from inside of Blender itself. So at the current stage of development, there is a release in GitHub that has where you can generate block mesh dict files from inside of Blender itself. And in upcoming releases, we are adding support for Snappy Xmesh, and we will slowly start working on solution modeling as well. Okay, so with that said, I will start upon Venturial. So if you have installed the Venturial add-on properly inside of Blender, you will see something like this in your right-hand side of your GUI. If you just press N on your keyboard, so to follow whatever shortcut I'm using, you can just see in the screen over here. So you can see all the mouse clicks and the shortcuts that I'm using over here. So if I press N, a sidebar will be exposed over here. And in that sidebar, you can see there is an option for Venturial. And this is our main GUI add-on, GUI application. So we got different tabs that is basically different parts of our block mesh dict workflow. And I will go on and explain each one of these tabs while making a simple mesh. In this case, I will be making a simple Venturi tube. The proportions, the size of the Venturi tube might be not how a conventional Venturi tube is made, because I'm just trying to demonstrate all the features over here. If you want, you can go ahead and reuse this add-on for your own personal projects, and let me know how it all worked and which areas need improvement according to you. Okay. So first of all, to start using, I will select everything in the current scene that comes with Blender, and I will just delete them because we don't need them. Then once we can open up Venturial, and we can create a new project over here. So I will just click on new, and it will give me this dialog box over here. So I can choose a case directory where I want. So I will just select a test directory that I have made over here, and I will just click on new. So you can see the new directory is taken up over here, and I'm using block mesh meshing tool, and it will generate a block mesh dict .txt file. Yes.
The new directory should be created inside the run directory of OpenFOAM folder, or can you create anywhere else?
You can take any other. You can take any other directory. So what is going to happen is, once you have selected that directory, like it can be an existing directory also. In my case, I have taken this directory. So this is an existing directory. I will delete this block mesh dict that is there over here right now. So I have selected this directory. So the block mesh dict will be generated here. Later on, while demonstrating in an OpenFOAM, I will copy that block mesh dict file into a case file that I have prepared over here. Okay.
Yeah, thank you.
All right. So that is the work of this Explore tab basically. We have selected the directory where the file will be out. Next, we will jump into Geometry tab. So this is where our main geometry will be declared. So in our case, since I'm making a Venturi tube, simple Venturi tube, I will take 3 blocks over here. So this geometry tab works as works the way as you would create a normal block mesh file. So first you would decide, okay, how to divide your geometry into different blocks. So in my Venturi tube, I will divide them into 3 blocks. And once I've decided what kind of blocks I want, which is hexaedrons, I will generate them. So now if I would just bring it over here a bit. Also inside of Blender, a few shortcuts. So if you have an external mouse, you can click on the scroll wheel, and you can click on the scroll wheel over here to rotate around the scene. As you can see in the shortcut also, the scroll wheel is clicking physical. And if you just shift and hold the middle wheel, scroll wheel, you can pan around the view. So those are the 2 useful navigational controls for Blender. All right. So now since the blocks has been added to the scene, you can go ahead and edit the shapes of these blocks to better fit your case. So let's say I want to make an Venturi tube, right? So I want this middle block to be 0.5 in size rather than 1 by 1 by 1. So default sizes of these blocks will be 1 unit by 1 unit, which you can check in this item over here. So you can see in the dimensions, there is 1 by 1 by 1. So it is saying meters over here because meters is the default unit used by Blender, but mostly it is just 1 unit that is our focus here. Yeah, I will go back to Venturi. Okay, I will select all those 3 blocks together and I will click on tab. That opens the edit mode. So now I will edit this mesh over here. So this button is for X-ray. You can also enable X-ray mode by Alt plus Z. All right. So what I would do is I will select this part and I will scale it to 0.5. But before doing that, as you can see, the scaling is occurring along all the 3 axes, X, Y, and Z. But I want to keep the length along Y axis to be 1. So for that, I will press Shift Y. So that makes sure that the scaling affects only along the X and Z direction. Okay, and then I will just write 0.5 and I will press enter. So you can see the width of the block has been reduced over here. Next, I will edit this face right here. I will drag this face out by 1 unit to the left. So G is for moving and Y is to fix the axis. If you just click just Y, it will be selecting the axis that you want. So if I don't click X, it will go along X axis. If I click Z, it will go along Z axis. So right now I want it along Y axis, so I will click it along Y.
Left corner bottom mouse icon.
Yes, this is a separate add-on that I am using so that people can follow me. This is not a default feature. This is another add-on that I'm using. Okay, so this is just so that the people in the meeting can follow along what shortcuts I'm using. All right, so where was I? Yeah. And I will move this face along Y-axis by 1 unit. So G is the shortcut to move anything, and I will select the axis Y, and I will set the distance. Okay, so the distance I can see in the top left corner, which is right here, that the distance this is a negative Y-axis. So I will just write -1 and I will hit enter. Okay, so it has been displaced by 1 unit along the Y-axis, and I will scale it to twice so that the length of this side will be 2 units rather than 1 unit. So the shortcut for scaling is S. So now I can scale it. So now I can scale it right here and S. And for now, scaling works in multiples. So if I hit S2, so what it will do is it will multiply 2 to the current size.
One question: what is the filter key for selecting only the face? And I think
you can if you just drag your mouse, you can just make a box selection. like this. Okay.
Till the whole block is only coming.
Oh, if you want to select the whole box, that is also possible.
Actually, could you please repeat?
Yeah, sure. From which part do you want me to repeat?
When you selected these three boxes and then the middle one, you decreased it in the size.
Okay. So when I selected all the three boxes, it was something like this, right? So you can select anything, any of the boxes by just left clicking. And I will suggest people to just look in this area so that you can keep a track of what keystrokes and mouse clicks I am doing. So you can just select the boxes by left clicking. And if you hold shift and then select, you can select multiple objects. Okay. So now if you hit tab, you will go into edit mode. Edit mode is the mode where you can edit the meshes in this inside of Blender. Okay. So now once I've entered edit mode, to make selection bit easier, I will enable X-ray mode as well. So this button right here, that is for toggling X-ray. So once I select this, you can see that you can see through the object right here. And if I disable it, it is disabled. So with X-ray mode enabled, what I would do is I would select the middle box and I will scale it along the X and Z to half the size. So as I mentioned, as I explained earlier, scaling the numbers you enter after scaling, that is the multiplier to the current size. Okay. So what you would do is, this is already done. Okay, I will just reload it. Okay. So this should be the original size of your middle block. So to scale this, what you would do is you would press S, so that enables the scaling mode. You can scale things once you have pressed S, and you would press Shift Y. So Shift Y, what it does, it tells that, okay, you don't want to change anything along the Y axis. So all my changes will occur only along the X and the Z axis. As you can see right here, the X and the Z axis are highlighted over here. And then I will I can enter the multiplier via keyboard. That what is the multiplier I want to scale. So let's say if I want to scale it to half the size. So I would enter 0.5. Okay. So now it has been scaled to half the size and I will press enter to finish the scaling. Same thing with this face. This face I would scaled this face by 2. So that would be just S2. And I moved it along the y-axis by -1 units. So that would be GY -1.
When I am pressing tab and after that S, it is not showing any effect.
Yeah, because you need to select the part which you want to scale.
I am not able to. I know actually whether it is selected or not.
If you select it, it will be highlighted like this.
So you are selecting by right click or something?
Yes, left click.
But when I am saying right click, it is opening some menu or something.
This is right click. I am doing left click.
Okay. And how to rotate the axis?
Middle mouse.
Like this.
Middle mouse.
So,
And if you do not have a middle mouse, just a second, Mr. Theme. If you do not have a middle mouse, you can just hold on to this gizmo and hold it and rotate it with left mouse button.
Okay. Okay. So I have selected, but I think I have selected the correct one. Then I have to press tab and then S.
No. To be able to select, first you need to select all the blocks. So by default, you should be in object mode, which is reflected over here. If you can follow my cursor, you can see that over here it is written object. So here everything is treated as an entire whole object. You cannot edit the shape or anything.
Okay.
Okay. So to edit the shapes of this, you need to first enter into edit mode, which you can change from here also. Okay. Once you enter edit mode, you can see that some vertices have appeared here. The texture has changed a bit. So you can see that it's tiny, but you can see that there are vertices that are more visible in the corners, and you
Yes,
can
yes,
select them
yes.
individually. So if you want, you can now you can select one vertex and you can change the shape of the mesh as you want.
How to change the shape?
So there are basic controls such as translate and scaling. So translation means if you want to just move something around. So shortcut for translation is G. Okay. So now when I press G, you can see that I can move the vertex around in in the 3D space.
So, but when I am selecting that vertex and pressing G, it is not
You need to
working
move your
that way.
mouse. After
I mean,
pressing G,
left
you can
click.
control it.
Left click.
Yes, you need to left click to select the vertex at first.
I have selected it. Then press G.
If you select it, it will glow orange or white like this.
Yeah, orange.
Yes.
Orange and white. I mean, white inside the orange. Correct.
Yes. So then you need to press G to start moving it, and then if you move around your mouse, you can see that you can move it.
It is not happening. I think I am missing something.
Does it look exactly like this, or does it look like something else?
It is not looking solid. It is looking transparent.
It is looking transparent. So like this.
Something like this. Yes, I can see the other all other vertices also at the same time.
Can you select them?
If I click on one, it changes some color.
That is to indicate which has been selected.
But I think edges are selected, not the vertex.
Is it like this? Look at my screen. Yes.
Not white line. That edge becomes black, darker.
Darker means it is not selected. Black means it is not
Hmm.
selected.
First, I went to object mode. All are orange in color. I have selected all of them by my left click.
Okay.
And but whatever you are able to do, I am not able to do.
Then from object
When
mode, you need to go into edit mode.
edit mode, yes, I am in edit mode, and when I click on a vertex, it is selecting three edges actually. Those three edges become orange.
It is selecting three edges. Like, is it something like
Yeah,
this?
yeah, something. But I am only clicking at one vertex.
Okay, most look at is it set to edge select right here? Right.
It is the left side one. Select mode, vertex select.
Select mode is vertex select. Yeah, then you should be able to select a single vertex. And those three edges, you can see that there is it won't be orange all the way. It will be just a faint glow like this.
Yes.
Yes, you should be able to move using G now.
Okay, so I should press G
Yeah.
and
Don't
then
hold it. Don't hold it. Just single press.
yeah, it is happening. Yes.
Yes.
I mean, I did not need to click it. Okay, I will try another one. Hmm. Now another one it is not selecting. Yeah, happened. Trick
These
was that
things.
I did not actually need to press the left button. That was the trick. I just have to hold the G button. That's all.
No, you do. You also don't need to hold the G button. Like you can see,
Oh,
like look at this mouse here. If I'm holding down the left button, you can see that the left button has been highlighted over here.
yes,
See,
yes.
And
Yes.
when I'm doing this, you can see that I'm holding my left button and selecting the entire face. Okay. Now,
Okay.
if I just hold G, you can see that the multiplier is increasing. That means I'm holding G that many times.
Okay.
But what I'm doing is I'm just pressing G once. And then you can see that in my mouse also, none of the keys are pressed. But I'm still, by just moving my mouse, I'm moving it.
Okay. Now, if I want to select the whole block like you are holding, how to select the block?
Just left click and drag your mouse. Like you select many icons in Windows. In Windows desktop, if you just hold left click and make a box, you can select multiple icons, right? So in the same way, you can do here also.
Yeah, happening. But suppose if I want to take the rightmost block, I mean, change its orientation, then what to do? How to select it? Rightmost. Yeah, this one.
Just
That
like
is not
this.
happening.
Maybe because you have selected only this block and then entered edit mode, then you cannot select this.
Okay, okay. I got it now.
That is why I told you to select all the blocks at once. So you can select multiple by holding shift. Here you can see shift is visible because I'm holding shift on my keyboard. Once I release shift, the shift will disappear.
Okay. Thank you. Thank you very much.
Welcome. Somebody else was having a doubt again?
Yeah. The question is, when I scale the block, middle block is becoming small, but it still continues the same shape proportionately, and the remaining two blocks become the individual three blocks. So the connectivity is not happening like convergent image and so on. So how do you do that?
I think you got something like this, right? Yours
Yeah,
is looking something like this, right?
correct.
Yeah, that is because, once again, you have not selected all the three blocks before entering edit mode. But this can be resolved also. Like if once you select all the three blocks, I will just select this face right here. Let's see. I will just select this face and then I will scale this face down to 0.5. So now it is of the same size as this one, right?
Okay.
I will just repeat the same with this. All right. Okay. So if there are no more doubts, then I will move on to the next step. I will move to the next step then. So once the shape is complete over here, what I would do is I would press A to select everything, because during the next steps we will extract data from this mesh. So in order to extract data, I need everything to be selected inside of edit. So I will press A to select everything, and then I will exit out of edit mode by pressing tab. Okay. So once I've exited, once again, I have to make sure that all my blocks are selected like this. And then I will click on compose. So what compose will do is, as you can see over here, these are three different meshes right now inside of Blender. So what compose will do is it will merge all the three meshes into one single mesh like this. So when you click on compose, you will get a prompt like, do you want to merge all selected blocks? And then if you click OK, it will merge everything. So after merging this, make sure you have completed your blocking. You have added all your blocks and everything before hitting compose, because this is an irreversible step. You cannot undo your composing step. You can still change your shape if you want, but it is still better to do before composing, because in case midway, if you realize you need more blocks for your geometry, then that will be better. Then you can add more blocks to your geometry. All right. So once this is done, you can just now the process is more simple from here. So you can just click on get blocks right here. So to extract the blocks data from here. So this get blocks corresponds to the blocks dictionary inside of block mesh dict. So you can see even the code is same. So you got hex, the list of vertices, the grading, and you got the number of cells. So I will just change the number of cells right here. So okay, so let's say I want different number of cells. Okay, I will just change the number of cells right here. Let's say I will just give 10 cells along every axis, or maybe 20. Let's keep it 20. Okay, so this is the blocks part over here. Then I will just click on get vertices, and this corresponds to the vertices list inside block mesh dict. So you can see there are 15 vertices there are 16 vertices in this mesh from 0 to 15, and these are the coordinates of the vertices. So with that, the job of geometry tab is done. And also, not to mention the convert to meters over here. So this is basically the convert to meters parameter inside block mesh dict. By default, it is 0.1, but if you want, you can change it to some other value if you like. And as you can see, just remember that this mesh over here is oriented along the y-axis over here. So the axis orientation will change a bit while when you port it into para view, but like the y-axis will be actually the vertical instead of the z-axis over here, but everything else will remain same. All right, so once the geometry is done, I can move on to the other tabs. So I will move on to the edges tab. So this corresponds to the edges dictionary inside block mesh dict. So here, if I want to make some curved edges, I can do that over here. So to make curved edges, let's say I want these. So this is my inlet, this face, and the face behind it is my outlet. So let's say I want my inlet and outlet to be circles instead of squares. So I can do that from here. So what I would do is, once again, I will enter edit mode, and this time select mode to edges. So earlier the select mode was vertices. Now this time I will select edge mode to select. So I will just click here, and I can see something changed. The vertices disappeared, but I can select the edges one by one right now. So the shortcut to do this is just clicking 2 on your keyboard. So the 1, 2, and 3 on your keyboard corresponds to the different different select modes inside edit. All right, so that is a bit advanced. Like this is optional if you don't want to know. You can just click over here also. But that is useful to know. In upcoming versions, you will get a button right here to enter the edge select. All right. So once you are in edge select mode, I will select the edge where I want my curved edge to be generated, and I will click on generate edge. Okay, so you can see the edge has been generated, and I will add one control vertex to the new generated edge. So let's see if I generate a new vertex. As you can see, a vertex has been generated, and you can see a custom edge right here. So the change in the mesh itself will not be reflected unless you import it into ParaView, because the GUI here essentially shows what your block mesh dict actually looks like. This shows that, okay, your blocks are arranged along this way, and you're modifying the certain edges in here, and this is the modified edge. It will not merge with your mesh right away unless you import it into ParaView. Okay. So now to make it a full circle, you need to adjust these coordinates of this control vertex right here. So to adjust that, what I would do is along y-axis, it should be minus 1.5 right here. So if you are not sure what your coordinate should be, you can check the grid lines right here. So in the grid, each unit is 1 unit. And as you can remember, I scaled it in the multipliers of 0.5. So this will be minus 1.5. And in order to make it a circle, the z coordinate of this vertex would be 1.414, like that, which is basically root 2. All right, so I will repeat the same process for all the other edges for this face and the other outlet face. So those who are following along with me, they can go ahead and do the same as well. And by default, the edge type is arc. If you want some other edge type, you can just change it from here. And if you want to change the type of a already generated edge, you can do this from here as well. Okay, so now we will add the edges for all the other, generate the custom curves for all the other edges. And those who are following along can repeat the same process with me. Okay, there has been some mistake in the, yeah. So the coordinates would be different for this edge. Since the length of this edge is 1, the and the coordinates for this is 0.5 to minus 0.5 to plus 0.5 along every edge. So the coordinates for this, for the control vertex would be minus, will be 0.707. And along the y-axis, the length would be 2.5. Okay. So with that, all our custom edges has been generated over here. So this shows how your final edge is going to look like. And the rest of the mesh will be adjusted once the block mesh utility has been run inside of. Okay, so that is the function of the edges tab. This creates custom edges for your mesh. Next, we will assign the type of boundaries to this to the mesh. So which are inlet, which are my outlet, which are walls, and like that. So moving on to the boundary tab. So once everybody has done that, everybody who are following, once they have finished up with this curves, they can go ahead and move to boundary. Over here, you will see there is a button for face select. So what that does is, every time in the earlier edges also, you could see that I was going into edit mode to do certain changes. So some new users, it might be confusing for some new users. So for that, I've included this button over here inside boundary as well. So in the upcoming versions, those will be included in the other tabs as well. So inside boundary, once you go into face select mode, you can see you can select every single faces properly. So I will just select my first face right here, and this is going to be my inlet. So let's see. This is my. I will select on new boundary. I will put the name as inlet. and the type I will put as patch. Okay. And once that is done, I'll click on OK. And as you can see here, one new boundary type has been added. Like this, the name of the boundary is inlet. This is of the type patch. And the vertices inside that face has been selected over here. I will repeat the same with all my other faces. So this will be my outlet over here. So I will just select that. I will write outlet and OK. So this has been created out. And next, all the other faces, they are going to be walls. So I will just select all those faces one by one. You can hold shift to select multiple objects. Okay, so okay, so once everything has been selected, let's see. Yes, everything is selected. So once all the other boundaries has been selected, I can also select multiple boundaries. I will put a new boundary and I will write, let's see. I will write walls for them, the plural walls. And the type will be wall. Okay. So I will click on OK. And you can see all the faces that have been selected has been added over here. So if you have multiple faces of the same type, of the same boundary, you can add them over here. Okay. So that is mostly it for majority of the features inside this GUI. And once again, if you select face select mode, everything will be you can go back into object mode, and then your mesh is ready to be exported. So another couple of things before I export the mesh into OpenFOAM, there is this visualize tab right here, with which you can visualize your certain things, such as the vertex indices that you can see here. So you can see that in block mesh dict, usually you write your vertices in a list and the indices are automatically assigned. So here you can see the indices of your generated mesh right here. So in case blue is a bit harsh to see, I will make them white. Okay. So, and I can also increase the text size of it. So you can see this is the 0, 3, 4, 1 face, and so on. The other vertices are also assigned the indices. You can also check the coordinates of those vertices, like here. With this, I need to reduce the text size a bit here. You can see the coordinates of the vertices right here. They are mentioned right here, like that. And also you can check what boundaries are all of the faces. So let's see. In this boundary tab, you can see that there are different colors assigned to each face. I just change this to red. Yeah. So you can see my inlet has been assigned red. All the walls are this yellow shade. And my outlet is blue. So you can visualize all these things over here. All right. So with that, our block mesh dict is mainly complete. We can just go ahead into the run tab and I can click on this generate block mesh dict dictionary. So once I've clicked it, you can see block mesh is generated. It pops up over here. And this will be generated in the folder that we have selected in here. So here, this is my test venturial dictionary directory. And this is the block mesh dict that has been generated. So as you can see, this was generated by Venturial. And yeah, this is the dictionary that we just made. So you can see all the things are there. So the vertices that I've generated are here. The blocks that I've generated, those are also here. The custom edges are here. And the different boundaries that we've generated. Merge patch space is entry because I have not done anything. Okay, so now we can just take this block mesh dict file, copy it, and I have a test case ready over here. So I will just paste it in here. So this test case is nothing but the Pitch Daily test case from Pitch Daily case from the tutorials. I am just pasting the block mesh dict file in here, and all the other files are the same. So this is just so that I can view the mesh inside of ParaView. I'm not running any simulation over here. Right? Okay, so with that, I pasted the block mesh dict. Then inside my terminal, I will go into the directory I will launch OpenFOAM. Okay, and let's see. We'll go into the test directory. All right, and then I will run my block mesh. So this will process the mesh, and yes, everything has been processed correctly. There are no errors. So now I will run Parafoam and visualize it inside of Parafoam. Okay, so if once I click on apply, so now you can see that the mesh that we have generated over here, this has been created. So you can see the inlet and the outlet, those two faces are circular, and the middle block here is rectangular. So this is not an ideal way to make a case for Venturi tube, but I have created it this way just to demonstrate the different capabilities of the tube. So I will just enable versus surface with edges and just solid color to visualize it properly. So you can see even the cells are generated properly. And usually when you would make something circular, you would use 5 blocks instead of just 1 block. The reason being the cells over here, you can see these cells are stretched badly and the results won't be good in this edges mostly. So that is mostly it for the add-on right now. Currently we are working upon implementing a GUI for Snappy Xmesh utility as well, and I'm expecting it to be released by the end of this month. So to catch it when it releases, you can visit our GitHub. So I will paste these links in the chat box itself. Okay. So I will paste these links in the chat box, the GitHub links. And in here, inside of Venturi, you can see the releases page contains the different releases that has been done. So this is the initial release the one that I have demonstrated. And the next version will, when it comes out, you can see it over here itself. Now there is another underlying project behind Venturial that is called PyVNT, Python Venturial Node Trees. So this is basically a Python package that interfaces OpenFOAM data inside of Python. So as you have seen right here, let me just open publish. Yeah, as you have seen right here. So this text file inside OpenFOAM, these parameters mentioned here are nothing but some data structures. This is a sort of C++. This is a custom syntax implemented by OpenFOAM, and these are actually data that can be parsed and interpreted into some other form as well. So PyVNT is a package developed by the OpenFOAM GUI team to read these data and convert them into a tree data structure inside Python. So now the benefit of that is once the data is available inside Python, I can write custom scripts to interact with that data. And then I can export my own text file with that data. So that Python package is also under development, and it is the underlying brain behind the GUI project. So in the future, we have plans to move out of Blender's interface because Blender's development cycles are too fast for us to keep up. So maybe sometime down the line, around 2 to 3 years, we will implement a standalone application. So for that to happen, we need to have a set API and packages there so that we can just build a GUI on top of our existing backend. So this Python package serves as a backend for that. So if there are people who like a bit more control on their on their data and likes to script something in their data, then they can give a go for PyVNT as well, and they can test it out and tell us what things we're lacking and what things might be used. So with that, I will end my presentation. So with that concludes my demonstration. Now, if there are any doubts, you can ask me.
Hi, it was very nice, the Venturi block generation and the method, whatever you showed.
Yes.
Is there any tutorial available for an annular, 3D annular geometry?
For annular geometry, there are no tutorials available. However, there is a tutorial for pipe and a constructed mesh that I have sent along the PDF file that we have mailed you. So
Okay,
since this
thanks.
is just the first release, and this contains many bugs that we have come across during our testing, we have decided not to release any tutorials in this version of Venturia. So in the upcoming version, we have fixed a lot of those bugs, and that is mostly stable. In that version, we'll be releasing more tutorial videos and PDFs regarding many cases.
Okay, thank you.
Well, Mr. Vivek Kumar said I could not follow the session. It was a bit fast. I would love to see the video or redo this again. Yes, Mr. Vivek. Yeah, as Ivan has said, the recording will be shared tomorrow. And also, I think you are having a bit of trouble understanding Blender's shortcut and GUI. So for that also, if you go to the release page right here, you can download this user guide.pdf. Inside this PDF, I have linked some learning resources for Blender itself, not just the GUI. So you can follow those videos to learn a bit about Blender's interface and the shortcuts that have been used. So with that, you will be a bit more familiar with working with Blender.
One more this multi-blocking techniques available. ANSYS ISM CFD, for example, if you have heard, so blocking is very easy to do there. So different types of grids like O grid and all are available where, like just like how we made easily grids can be added, and later the number of sizes vertices can be decided, and mesh will automatically generate that. So my question is, do you have different types of blocks? There is like O grid block. There are multiple types of grid blocks by default. So those things will be included in future. Or another question is boundary layer meshes. So you said wall a boundary could be named. I really want to have a boundary layer mesh near the wall. So is it possible with the present version?
Yes. So I'm sorry if I don't clear it properly, because I specifically do not have a background in CFD, so that is still new for me. But as far as I could understand, uh, there are different kinds of blocks in OpenFOAM itself. So what I've demonstrated over here, that is the hexahedron block. So there are also different kinds of block inside OpenFOAM itself, such as wedge, prism, pyramid, tetrahedron, etc. So those all will be implemented in the upcoming versions also. And within the boundary also, yes, patch and wall is one boundary, but there are also different more types of boundary over here that can be implemented inside OpenFOAM. And so that is what I can say. And if I get something wrong, I think Ivan, you can correct me.
Yes, Diptanshu. So what I was, I think, trying to ask was the grading part. So currently in the current version of Blender that we have, the grading is set to simple grading and it is uniform. But in the upcoming version that we have, you'll be able to adjust your grading as well. So I hope that clears your doubt.
Yeah, thank you.
Yeah.
About the O-grid, like we can do that in ISMCFD.
Yeah, so for O-grid and all those, like Diptanshu showed you how you can make curves and all. So if you have a cylinder, you can keep that hollow. Basically, you won't have a block over there. Whereas the blocks that are surrounding it, you can manipulate those and you can give a curve or an arc to those. And you can basically make your O-grid in that way. So you will have multiple blocks connected to each other, and then you manipulate each of those sides as and how you want to basically make your O-grid. Yeah. And Diptanshu, there's one doubt regarding, is it possible to convert ASCII file blockmeshdict to geometry using Venturial?
Yeah, so not currently, but we are working on that also. So here you can see, in the Explore itself, there is a new option which I've used, but there is open case and build mesh options and make import options also. So we are working on making those buttons functional as well. So the open case would basically be taking a blockmeshdict text file and then importing it inside in Blender itself. I hope that answers the question. And if there is any more question, please feel free to ask.
You were showing me the user guide on your GitHub page. I was not able to get to that file.
Yes, I pasted the GitHub link in the chat box itself. And that user guide is the same file, same PDF file that has been mailed to you as well before the meeting.
Okay. No, I have got to the page of GitHub, but how to locate that file? I am just trying
It is
to
under releases. So let me just put it.
releases.
Yeah. Here you can see these are the initial release over here in the right side.
Just 1 second.
I'll just paste the link over there.
Initial releases.
I
Fine,
pasted
thank
the
you.
link in the chat box.
Okay. Thank you.
Welcome.
Hello, Vikansu. I think somebody had asked that we can have a Q&A session on the, for the airfoil case. So it was giving some errors. I just wanted to clear out on that issue. So what was happening was in the zero folder, so which I had emailed the template case. So I'm talking about the dynamic mesh case. So dynamic mesh case of turbulent airflow. So the template case which had zero folder, in the zero folder, so if I can present it, then it will be, I think it will be better. So this was the zip file I had emailed you. So inside this, so this was the file. So if you can see inside the zero folder, the boundary conditions, K, suppose you say K and omega. So let's open this. So what you can see that the value is set to uniform 0 in both the cases. So what I had planned was I will calculate these values and ask the user to input it on their own. But at that time, I think due to some time limitations, these values were not changed on the zero folder, and the initial conditions are always stored on the zero folder. So the floating point exception was, I think, occurring due to this error, that is this value being 0. So you have to change this value to the value that we had calculated. So if it is k omega, then it is 0.11. So this was the calculated value. And similarly for the k, it was 3.75 e minus 3. So just make sure that this is corrected. And now if you run the simulation, then the simulation won't crash or won't give floating point exceptions. So and another thing was, there was a command called cpr0.original to 0, but it did not override the 0 folder because the 0 folder was already created. So I also suggested you all to delete this 0 folder. So if you have deleted the 0 folder, now if you run, now the phrase that is the original folder, that was 0.original, will be copied to 0 folder. So in my 0.original, the conditions were all right, but in the 0 folder, the conditions, the boundary conditions values were wrong. So that was creating the problem. So I hope you understood what was the underlying reasons behind that problem. So if you have not understood, or if you have any issues, then yeah, you can just delete the 0 folder and then edit the block base. Yeah, that will do for it. Or you can make the changes in the 0 folder and in the inside the k and omega file. So that will also run the simulation. You can do either of them, either of it. So basically, floating point exceptions occurs when we get like division by 0 cases, and while we calculate like the turbulent viscosity, that is nu t, then it is a calculated boundary condition. So what we had assigned was the 0 internal field values, that 0 values at the wall. So that created division by 0 condition, and that causes floating point exception. So you need to check that and correct that. Thank you.
Okay, so thank you so much. And bye bye for today.